Okay, guys, we're back again. So now went through our homework assignments. So now we are ready to start on the new assignments for this week. Again, I'll refer you back to our little handout. We've done the first page, and today's lessons are going to be, I've made you some notes. These are covering lessons 85 today. That's what we're going to start with. So let me just review a little bit. We reviewed the GCF method, and then we learned the reverse distributing method. So sometimes those two methods don't even work for us. This is lesson 85 that we're on. You can take out your packets. This is where we'll start to work here in just a few minutes. All right, so let's say we're given this one. All right, new problem to work with. We have x squared plus 4x equals 2. Now, some of you are going, wow, they got an x in common. So you start thinking about pulling out and doing a GCF. So let's just play with that for just a second. Let's say you did just go ahead and pull out the x and came up with x plus 4 equals 2. All right, here lies the problem. Notice we have a 2 on this side. We don't have a 0. Because we don't have a 0, that idea of something times something just got much bigger. There's an infinite number of things I can fill in for x here and then multiply it by something else that could give us 2. Okay? So that's not going to work for us because this x, and remember, whatever x has to be the same thing throughout the whole problem. So it has to be the same. So if I pick, maybe, you can't come up with something on this side that when you multiply it by x, you'll only get 2 without changing it. You can spend forever trying to figure out what that combination would be. So my point of this is the GCF method does not work when you have something other than 0 on the other side. Okay, so we can't just simply pull out and do the something times something equals 2. It has to equal 0. All right, so that method will not work for us. So this one's offering another one. And this lesson 85 is telling us about a method called the completing the square. And it is a cornerstone of algebra. It's a very important method, and you'll use it quite a bit. Now, I just want you to bear with me a little bit. Whenever your homework says completing the square, I just want you to think about what I want your problem to look like. It says completing the square, you're going to instantly set your problem up like this. See my squares? You're going to complete the squares. That's not really what it means, but it's a visual aid to help you. Completing the square, you make squares, and you make both of them. After you've trained your brain to do these problems and it's not so much issues for you, then you can stop drawing the boxes. But to start off, let's draw the boxes because people tend to forget both. They'll put a number in here and won't put it in on this side. So when I say, or the directions say completing the square, you're just going to rewrite that problem and make it look like this. Okay. Now here's what we do for completing the square. Now, completing the square will always work to solve this trinomial. And this is a trinomial. We could pull that 2 over here if we wanted to and have a trinomial. But this method will always work. And this method is based off the perfect square. Now, just take a little side trip here. Marker's dead. All right, all my markers are dead. Let's just review just a little bit about the square. Remember that the thing about the square is all 4 sides are equal. So as long as we know what one side of that square is, it's the same. So if I said it was x, and I asked you what the area of the square was, you would say it was x times x squared. Okay, x squared. Well, I could make other things too. It could be an expression. I'm going to write this over to the side just because I don't want to get in my way. Let's say I said x plus 2. Well, that means that this side is x plus 2, that side is x plus 2. It also means that if I wanted to find out what the area of this square is, I would do x plus 2 times x plus 2. And that would give me the area of this perfect square. Because of the same number, that's really nice and neat for us. So that is what we're after. We're after some way, some formula that will help us get this perfect square, where both numbers are the same on both sides. That's what this method is going to give us, completing the square. And it doesn't mean the square like this, it means this square. Completing this perfect square is what we're after. To get it, here's what you do. See the middle number? You're going to take half of this coefficient. And notice that you need to get them in descending order. So you want your x squared and then your x, just in case in one of your problems give them in reverse order or something. You're going to line it up because we know we do by the power. So x squared, then x, and then our digits. Well, we don't have anything right here. That's the way we want it to be. In order to complete the square, there can't be a number here. If there was a number here, you'd have to send it to the other side. Okay? So, to complete this method, you're going to look right here at the coefficient of just the x. Okay? And this is on your handout too, a little summary of this. You're going to take half of that coefficient. Half the coefficient. Half the coefficient. Half of this coefficient is 2. That 2, you're then going to square it. You're going to raise it to the second power. So half of 4 is 2, and 2 squared is 4. Now, it just happens to be the same number. It doesn't always work like that, okay? It doesn't always have to end up being the same number, okay? But you're going to take half of the coefficient and then square it. So if this was 6, then you would take half of 6. That would give you 3. And then if you squared it, you would have 9. Okay? After you have squared that number, in this case it was 4, that 4 is what goes in this square. And what you do to one side, the golden rule of algebra is you must do it to the other side. Okay. Now, this left-hand side of the equal sign is we are used to seeing. We have done this problem now for several weeks. Come up with all the factors that you add together that will give you 4. You might say 1 and 4, positive 4 too, by the way, negative 1 and negative 4, 2 and 2, and negative 2 and 2, negative 2. Those are all your choices to get 4. But you need not only the ones that will multiply to give you 4, but you need them to add to 4 as well. You look through your list, the only 2 that will give you a positive 4 is 2 and 2, positive 2 and positive 2. Set up your little something times something. X plus a positive 2, x plus a positive 2. Well, look what we just did. We created a perfect square. Also, look what you did. The number that you halved was 2. It was a positive 2 because it was a positive 4. So it was a positive 2 here. It will always, the number you fill in the blanks will always be what half of that coefficient is, including whether or not it was a decimal. For instance, if I gave you 3, if 3x was here, half of 3x is 1.5, 1.5. You can have a decimal in here just as easily as a whole number, okay? So this here is always this. Well, now let's look at this. We're algebra students. We know a better way of writing this. We don't have to write it down 2 times because that's repetitive. We could, instead of writing it down twice, just put the exponent up. Remember, the exponent says write this down twice. So this is the same thing. We're going to write it like this, and you'll see why in just a minute. Okay? So half the coefficient was 2. 2 squared was 4. Set up your parentheses. That whatever you got for the half coefficient goes down here. Now remember, if this is a negative number, then half of that is a negative number. So if that was a negative 4, it would be a negative 2. Okay? So that's here. Then you do the other side. 2 plus 4 is 6. Now this is the problem that we're used to working. We don't have any adding and subtracting to take care of. We don't have any multiplying and division. So now we're ready to take our roots. We have an exponent of 2 here. We must take a root of this side so that they will cancel out. What you do to one side, you do to the other. That frees our answer here. Now this depends on what your instructions told you to do. If your instructions told you to estimate, then you would plug this answer in your calculators and get an estimation for it. I think the one I put on your sheet, I didn't do that. I wanted you to see what it was going to look like if it didn't ask you to do it. But we're still going to go ahead and set up our two different problems. Remember, we're taking a root of a number. It's either plus or minus. It could be either one, a plus or a negative. So we're going to set up two columns. X plus 2 equals a positive 16. X plus 2 equals the root of a negative 16. And then you just solve it like you would do any other problem. You pull your 2 to this side on this one. So you would have a positive root of 16 minus 2. Pull it on this side. You would have x equals the negative root of 16 minus 2. Just depends on what your instructions told you to do. If they wanted you to estimate, then you would have a number here, and then you would just follow through. Okay? Ryan, what is that one? Oh, I did 16. It's 6, by the way. I put a 1 in there. What's the square root of 6? I'll make Ryan do the work. 2.45. 2.45. So this would equal plus 2.45 here minus 2. If it told you to estimate, or it could be equals a negative 2.45 minus 2 on that side. So that would be x equals 0.45 or x equals negative 4.45. It just depends on what your book asked you to do. Okay, if your book asked you not to estimate, then this would have been your answers. If it asked you to estimate, these would have been your answers. And remember, I told you that it's okay. You can write that plus minus square root of 6, and then you could have did your minus 2 as well. This here does not have to be wrote twice, so this would have covered both your answers if you remember to put both your plus and your negative. So you could have just wrote this, and I would have been fine with it. Or you could do both. That's okay as well. All right? This is called completing the square. There's one more rule to this completing the square. There cannot be any coefficient right here. There cannot be a number sitting beside the x squared. Okay? If there is, we have to get rid of it before we can use this method. Okay? And we're going to come across that in the next lesson. So that was 85. I'm going to go ahead and teach on everything, and then we'll do our packet. So we'll just listen and get all the new information. All right. So now moving to 86. I hate lesson 86. I think 86 was a very complicated lesson to teach you a very simple variation to the rule. I'm going to very quickly cover it, just in case you're listening to your lecture tapes at home, just to maybe make it a little more simple, because I know Dorky Dude on there gets a little complicated. So try not to spend too much time on it. In lesson 86, they are trying to give you a real life story, which we know are never real life, but this is what they've come up with. Somebody is going to hire you to build a deck around their pool. Okay? Now, you're a contractor and you're going to build a deck. Now, most of the time, people go out there and go, I want a 10-foot deck around my pool, and they want you to build that. But this is not the case. We have to pretend that this owner has his pool, and his pool is, draw it up here. Here's his pool. Can you see that? Okay. His pool is 61 feet wide and 40 feet long. Okay? So we can very easily come up with what the area of his pool is. We would just multiply this, 2,440. Okay, that's the area of this pool. All right, so we're supposed to believe that this homeowner decides he's going to go to Lowe's and he's going to purchase the lumber for his pool. But rather than saying he wants a 10-foot one around it, he goes, I just want my deck around my pool to equal the exact area of the pool. Okay, so he goes to Lowe's and says, load me up 2,440 square feet of wood. And now you as a contractor have to figure out how wide that pool is supposed to be, or how wide the deck around his pool is supposed to be. So here's his deck around his pool. Okay? What do we really have? We have a rectangle inside of a rectangle. Okay. So we know that the area of the bigger this ring around it here has to equal 2,440 as well. Okay? But we need to know how wide that deck is supposed to be built. So whatever we're looking for is going to be what? What do we assign that value as? X. Okay? So the width of the pool from here to here is X. Okay? In fact, I'm going to move these just a little bit. Maybe it'll help you do a visual a little bit better here. I'm going to move these to the corners. You'll see why in a minute. So we want from here to here to be X, the width. Okay? Same thing up here on the other side. We would want it to be here to here to be X. Okay? And you would want this all the way around. So like from here to here, you need to know what X is, right? Maybe even from here to here. Okay? So, let's look at this. What can we tell from this? Well, we should be able to figure out that the entire structure, what would be the area of the whole structure? We know the answer because we know the area of this is 2,040. So we know the area of the other part is 2,040. So what would be the whole area of the whole brown triangle? Anybody? Anybody? If you did that, I left my papers in my book. It would be the 2,040 for the pool and the 2,040 for the deck would be 4,880. See that? Both of those added together. So that means everything on the brown, the big triangle, the whole structure. Okay? So the whole structure, the entire structure, is equal to area of the pool. Let's do it in words, and then I'll put in my numbers. So that would be the area of the pool. That would be the area of the pool plus the area of the deck. The whole structure equals the area of the pool and the area of the deck. And we know that all of that equals 4,880. Now, we need some expressions to get here. This one's easy to do. We know what the pool is. The pool's area is very simple. It's the 61 times 40, right? What we're looking for is we need to know these lengths of these sides, right? We need to know what this is and this and this and this all the way around. And what that, and it's going to be the same size all the way around the entire deck. So if we were to do that, if we found the area of the pool, we need to do, well, how do I want to put this? Hold on one second. Let me get my note out and see which way I did it. All right. So if we want the area of the whole entire structure, this whole thing, then we have to be able to multiply this one by that one. Okay? If we want the area, that's what we got to do. I put plus. We want to do multiply. We need to multiply the two together. I'm sorry, I'm getting confused here. That is plus. We want the whole area, and we need to multiply the whole structure here. We know that these two are independent, and we need the whole structure. That means we want to multiply these two sides together and get this over on this side. So let's talk about that. What does that mean? If we want the whole structure, let's look. If we wanted to find out the side length to this side, we know the pool is 40, the width on this side. But it's not just 40. We have the width of the deck. Okay? We have this width, and then we have this. So if we said the deck was 5 feet, it'd be 5 foot here, then the 40-foot pool, and 5 foot here. Now, what would you do with those numbers? If you wanted the length of this side, you would add them. Now, most kids say they want to multiply them. They tell me it's x squared. But we're going to add them. This x plus 40 plus this x. So when you add two x's, you get 2x plus 40. Okay? Now, if we did it for the other side, look what we have. We have the original pool, which is the 61, but then we have the width of the deck, whatever it is. So we have x plus the 61 plus x. Again, when we add our x's, it's 2x plus 61. All right, so the whole structure would be equal to this times this for area. We know that it has to total this. Okay? Because we just said that. We know the structure was equal to the pool area and the deck area. That's the area. We can see that visually. And we know that those two numbers have to be 4,880. So we know that this multiplied by that must give us this. Do you agree? You see that? So if we set that up, you would have 2x plus 61 times 2x plus 40. And you know that that's going to equal the 4,880. Now, to save you some work and not so much time, because like I said, this is a real complicated problem, just to show you a very simple exclusion to this rule that they're trying to teach you. You do all the math here, and I'm going to do it all for you. Isn't that nice of me? I made my other classes do this. If you did this math, and this is in your book as well, you would distribute your 2x to your 2x and then your 2x to your 40, and then 61 to the 2x, and 61 to 40, you would get this. We combine our like terms, and I'm just going to kind of speed the process up a little bit. I know we know how to move things around and combine our like terms, but after you do all that and you combine all your like terms, you're going to get an answer of 4x squared plus 202x minus, well, I take that back. You're going to get that equals 2,440. That's what you're going to get. I'll give you a second to digest that for just a minute. I just added my terms together. We're not done with this problem yet, believe it or not. Now I got to erase this to go kind of give me some room. We're just now getting to the crux of what this lesson wanted to teach you. That's just after I added everything together. I added everything together and I moved my 2,240 to the other side. I undid this and moved it to the other side. I end up with that. Okay, now, couple things. We're still working out this. We're still supposed to be coming down to what x equals. We're a long ways away from being able to figure out what x is equal to. The first thing you might thought was, well, GCF. Well, GCF is not going to work here. We have numbers on both sides. We're not dealing with a binomial, and there's no common numbers amongst anything. So the GCF method's completely out. So then maybe you thought, well, let's move that 2,440 to the other side. Let me see if I can factor that out. So you go and you do that. Let's just pretend like you're going through all your different methods here. And you move that over here to this side. The second method, and you set it equal to 0. That's great. At least you thought about it. Now, if you have to sit here and come up with every factor that you can multiply together to give you 2,440, but also add together to give you 202, we're going to have a problem. That's not going to work for us either. So that's not going to work. So let's send this back over to the other side. So then you know you have your third method. And you want to do completing the square. Because the other methods didn't work. But what was the one thing I told you that could not exist for the completing the square to work? Do you remember, Rain? This cannot happen to be able to use it. It cannot have a coefficient on the x squared. Remember I pointed that out when we learned that method. It cannot have a number sitting beside the x squared. There cannot be a coefficient to x there. So now we're kind of in a problem because we are out of methods. So you need to figure out a way to make one of these methods work. So we have learned all through this how we can manipulate problems. How, and this was the whole point of this whole stupid problem, was to get you a coefficient here of x, but you had to figure out how to figure it out, what to do with it. That was the whole point of this pool exercise. Remember, we're still trying to solve the width of that pool. So, let's think about it. What type of math is going on between these? They're being multiplied. Correct, Ryan? So if we wanted to get rid of that 4, we could divide. That's good. We can do that. We got to make sure, though, and I need everybody to really understand what I'm telling you now. If you want to divide this x by 4 over on this side, that's perfectly legal. But what you do to one side, you have to do to the other. That's what everybody does. But that 4 also has to go here. You have to divide everything by 4, not just the one that you want to work with, because everything has to be done by that number. So even this middle term here has to be done by 4. When you do that, we start to get a little something that's a little easier to work with. Let's see what happens. These go away. That leaves me my x squared plus. When When you do the math and you put 202 divided by 4, yes, you get a decimal. You're going to actually get 50.5. That's okay. No harm. And then we're going to have, when you do on this side and you divide that out, you're going to get 610. Now you're thinking, okay, we're down to some more reasonable numbers. You could still see if you move this over here. Yes, your other method of being able to write down all the factors that equals 610, but multiply or add together to give you 50.5. But that's too complicated. We really want to use that new method that we learned, the completing the square here. So just think when you have numbers on the other side of the equal sign, consider using your completing the square method, okay? Especially if they're big numbers, because it's too hard to do the other way. If they're little numbers, then you could probably pull that over there and come up with the answer. If there's no decimals involved, then they're little numbers. If you have decimals involved or big numbers, completing the square is probably going to be the best option. So I said completing the square. So the first thing you're going to do is set up for completing the square. That means you write the first part down, plus you're going to add a square equals 610 plus and add another square. I have you add these squares because people forget about this one over here. They get so wrapped up in doing the left-hand side of the equation that they forget to put something over here. So if you do it right away and go ahead and set it up like this, it's less likely for you to forget that. All right, so the first step was what, Ryan? If we want to do completing the square. If you want to do completing the square, you have to take half the coefficient. Half. Okay, you got your calculator, you do half. Hopefully you can come up with that without doing it, but you can't. I'm going to write it. Now remember the sign goes with it. This is a positive, so this is a positive. Half of this is 25.25. Okay? Half the coefficient. Then you square it. Okay? So that's real important there. You have to half it and then square it. So it's 25.25 times 25.25. And yeah, you get a really ugly number, but that's okay. I actually got to make my squares a little bigger. Now that I think about it. All right. 25.25 times 25.25 is going to give you 637.56. Ugly numbers. Remember what you do to one side, you do to the other. 637.56. Now, the second part of that was we were going to set up our parentheses. Remember, we don't have to write it down twice. We can, and it might sometimes help you to write it down twice. But we also have the option of writing it one time and squaring it. So this is going to be what it looks like. What goes in here is our x, because x times x gives us x squared. So that's there. And then it's always going to be what this first part was, the half. And it was a positive 25.25. That's what goes in. And the decimals are perfectly fine. There's nothing wrong with those. And then on this side, we still have our 610 plus 637.56. All right. Awful lesson. Hate this lesson. I'm just pulling this back up to the top, what we just did. So we have our x plus 25.25. Actually, I'm going to write over here too a little bit. X plus 25.25 squared. And then you do the math over here, 610 plus 637.56, and you're going to get 1,247.46. 46? 56? 56. Okay, we're getting there, people. We're almost done with this stupid problem. Here we know what to do. From here we take we want the 2 to go away. We want the exponent, so we're going to square both sides. And because that square can be both positive and negative, do we have to consider the negative? Well, actually, we do have to consider the negative at this point, but just remember, we're not going to consider our answer if it's negative. All right, so here we go. You do this side, x plus 2, 5 equals, you put this into your calculator, and you're going to come up with 3532. 35.32 plus or minus 35.32. We then divide up and make two different problems. You have x plus 25, a little bit bigger. You have to do x plus 25.25 equals a positive 35.32. And you have to do the other way. X plus 25.25 equals negative 35.32. Okay? Then you complete the math. Just undoing both sides. So we have additions, we subtract. On this side, and then you do it on this side. And a negative plus a negative is a bigger negative. So we have our two answers here from completing this problem. And then I would want you to tell me if this was actually a problem. They'll never give you anything this complicated to work. But, well, they could give you this part. They won't give you the pool problem, but they could look something like this from here out in a word problem. But from this point, and the answer to our problem would have to be this one, because we're dealing with measurements. The measurements cannot be a negative. You can't go to Lowe's and have them copy something or cut something to a negative measurement. So it must be a positive answer. So it would have to be the 10.07. So that means that the width of that deck is 10 feet and 7/100 of an inch, or whatever they measured it in, but 7/100 of the unit, or whatever they were measuring. Okay, which is not a very logical answer to the problem, but it is an answer. That's all. The whole purpose of this whole entire lesson was to show you that coefficient of 4 on that square root of 2, and make you do that. Now, for the last couple lessons that we have to go over, they're not nearly as hard. In fact, I've already taught you the information in these, but we're going to review them. So the next two will go really quickly. 87 is relationship tables and equations. You know, I've already showed you that we can manipulate equations. And 87 is showing sometimes we manipulate those equations and put them in a chart. And they did one based on distance. Remember, our distance formula reads distance equals speed multiplied by time. Now, if I told you the speed was 60 miles an hour, I'm just going to set it. It's 60 miles an hour. It's standard. It's not going to change. But we want to make up a chart that would show the relationship between distance traveled and time. So we got distance here and time. Now, I'm just going to do one of these problems. If I wanted to know the distance that was traveled with the speed of that 60 miles an hour, there's my 60, and 1 hour. 60 miles an hour, 1 hour. That's real easy. I think y'all can do that. 60 times 1 would be 60. So the distance would be 60 in 1 hour. Now, once we have that formula filled in, and 60 is the standard, then this is just showing the relationship between the distance and the time. The speed is set. It's not going to change. So the only thing that changes is the time. And we would just go back and forth and plug in different times. You can see very easily if I filled in a 2, then the distance would be 120. If I filled in a 3, the distance is 180. If I filled in the 4, distance would be 240. Rather than working each individual problem with this and then plug in individual, it's just showing you that we can show a nice, neat little relationship showing how the numbers relate to each other. That's all that one was showing you. And it could apply to anything. It doesn't have to be a set formula that we're used to seeing. It could also just be something random. I could just come up with something off my head. I could say y equals 3x plus 1. Okay? And then we can make a chart. If I said x was 3, then you can go and fill in that 3 into this problem. 3 times 3 plus 1, 9 plus 1 is 10. So if x was 3, y must be 10. Okay? If I said x was 2, then you could go 3 times 2 plus 1. 6 plus 4 is 7. So if x is 2, y must be 7. And I'll do one more just to show you. If I said x was 1, we'll just continue our downward path here. Then y must be 3 plus 1, which is 4. Okay? So they're just showing you that we can organize our thoughts into a nice little pattern. What they might do is do something like this. They give you the formula, they give you a chart, but one of them might be wrong. Well, let's see that one. Well, let's see. That was 4, right? They might give you something like that. It asks you to identify which ones were wrong. So you would just fill in for one and see what you get. So if you filled in 4 here, then that would be 3 times 4 would be 12. 12 plus 1 would be 13. Then this one is wrong. If I filled in 0, 3 times 0 is 0. 0 plus 1 would be 1. So y would be 1. This one's wrong. The only one that would be correct is this one. And that's okay. So you just, it might ask you, is this equal to that? One of those equivalent fractions, one of those equivalent questions. And then 88 is just telling you we can manipulate those formulas, which I have showed you all along. In fact, I showed you this not too long ago. Taking our other formula here. This is solved for distance, but we could just as easily solve for anything else in it. We could decide we want f by itself. If we want f by itself, we have to divide by t. So f would equal d divided by t. If we wanted the other one by itself, if we wanted t by itself, then the f has to go away. So therefore, t would equal d divided by f. So you could have 3 different equations from that one. You can manipulate it however you need it to work for your class, for whatever problem you need. Now, it's up to you whether or not you want to work that problem, if you want to manipulate your formula before you plug in your data, or if you want to wait until and keep the original one and plug it in. It works both ways. You could, if you were given distance and time but needed speed, you could surely plug it in first and then move everything around. That's acceptable. Or since you know you need speed, you could just use the speed formula and manipulate it first and fill in. Whichever way is easier for you to see. Okay? And the last thing in this lesson is just simply showing you that you can solve for one variable in the terms of another. So we can have something like this. 2x plus y equals 10. If I asked you to solve for x, so we got to keep the x, and that means we want to get rid of the y. So that means this y is added to the x over here, so we would undo with subtraction. Okay? So now we would have 2x equals 10 minus y. We still need x by itself. These are being multiplied together, so we would undo with division and move it to the other side. This method, what they're asking you to do here is solve for one variable in terms of the other. I asked you to solve for x. So solve for x means we have an answer for x. X in terms of y means we don't know what y is. So all we can do is come up with another expression that we can fill in for y. Okay? We can take that same problem and solve for y. I could tell you to solve for y in terms of x. That means we want to keep the y. That means the 2x is added to the y. That means the 2x has got to go away. So when you do that, y would equal 10 minus 2x. You just need to, but you've got to remember to follow your rules of undoing algebra. You need to follow your thing. So we have to do our addition and subtraction first. Don't be dividing by something if it's being added or subtracted. Okay? All right, so this is going to end this video on instructions, and then we're going to have a third video to show you your packet. Okay? See you in a few.